June 2020, paper 3. Okay, 3.1 and 3.3. Let me see if I've named it correctly. Walaikum assalam. Let me change my name. Okay, so again, a reminder to submit that poll, please, if you haven't already, so I can decide which questions to do from this paper. And also, if you want to ask me something, send a message to the account that says message here. Or you can also raise your hand and ask your questions verbally after raising your hand. Okay. Okay, so let's begin with this one. June 2020, paper 3, variant 1. This is what we want to do today. Let me have a look at the poll in case you guys have responded. Okay, I'll choose, of course, some questions myself as well, because these days a lot of people are missing classes because of maybe their schedule for exams. So since many of them are not here, I will be deciding which questions look difficult myself as well. Okay. So yeah, you can see if this is all done. Okay, let's begin then. June 2020, paper 3, variant 1. We're doing difficult questions from this paper. Okay, let's start with this. So it says, find the set of values of x for which this is less than 5 raised to power x. Give your answer in simplified form. Okay, now you have to solve this inequality using logs. It works exactly the same way like equations. You take log on both sides, apply the multiplication law, and then find the value of x from that. Not that difficult. You can do that. Question number 2, you have to expand this and then state the set of values for which the expansion is valid. What you have to do is you have to first take 2 common outside. That leaves you with 2 raised to power minus 2. Then you have 1 minus 3x over 2 whole raised to power minus 2. And then you will expand it. In the first part, you will apply the formula and expand this thing. In the second part now, it says state the set of values of x for which this expansion is valid. How do you approach these problems? The formula has 1 plus x raised to power n. And in this case, x is supposed to be between minus 1 and 1. In your expansion here, the expression is 1 minus 3x over 2. All you have to do is put this thing, ignoring the sign, between minus 1 and 1. So you'll say 3x over 2 has to be between minus 1 and 1. And that gives you, so if you multiply the whole equation by 2, multiply the whole inequality by 2, divide by 3. What does that give you? That gives you x between minus 2 over 3 and plus 2 over 3. So that is supposed to be the interval that we've got for x in this case, okay, for which this expansion is valid. So whatever comes in place of x, ignoring the sign, you're just going to put that thing between minus 1 and 1, and then you will find the corresponding values of x from that. Okay, so this is going to be a result here, x between minus 2 over 3 and plus 2 over 3. For the second part, okay, you can do that. Then this is trigonometry. You just have to apply the compound angle identities. You'll get a quadratic equation in terms of tan, and then you can solve that. Again, not that complicated. I'm going to skip this as well. Question number 4, this is about differentiation. You can apply product rule here and then find the second derivative as well. Again, not that difficult. Question number 5, you have to find the remainder, the quotient and remainder, when this is divided by this. That's simple long division, the first part. And then you have to use that first part to find the exact value of this integral. Okay, now how do you use the first part to find the exact value of this integral? This will be that kind of integration, that type of integration where you have to divide your fraction into two parts, quotient plus remainder over divisor. It's an improper fraction, right? It's an improper fraction. So what you would do is you would divide it into two parts, quotient plus remainder over divisor. And then you will just integrate those separate fractions separately, right? So all you have to do is do the division in the first part. You would get a quotient from that and a remainder from that. You will break this fraction down into two parts like this. You will say it's quotient, whatever is the quotient that you get from the first part, plus the remainder over divisor, which is x squared plus 3. And then you integrate these two expressions separately, okay? And it should be easily doable after that. Let me actually do it for you. We discussed this method when we teach this, but let's actually do this quickly because it is slightly complicated. So I'm going to go through this whole process. Question number 5, part 1. First of all, let's do this division. 2x cubed minus x squared plus 6x plus 3. We need to divide this by x squared plus 3. Now you see the x term is missing. We can write this as x squared plus 0x plus 3. All right, the term that's missing, we put 0 in place of that. We treat that coefficient to be 0. Now x squared multiplied by what is going to give you 2x cubed? 2x into x squared, that is 2x cubed plus 0x squared plus 6x. Okay, now you change the signs, it becomes minus, this gets cancelled, and apparently this also gets cancelled, and we're just left with 3 from that. Okay, so this is just 3, the remainder, right? And that's it. Okay, this is all that you had to do in the first part. I'm sorry, this was supposed to be 6. Yeah. Yes?
Yes, sir. What about minus x square?
Okay, I'm sorry. Just give me okay, I'm sorry. I missed that. Just give me a second. I'm disconnected from my other device. I'm just checking what the problem is with that. Just give me a second. It's disconnecting again and again. Okay, so now it's working fine. I'm sorry about that. Okay, so let's do this. So I was actually trying to make that work alongside. Okay, now let's do this division. So x squared into 2x, that gives us 2x cubed. 0x into 2x, that gives us 0x squared plus 6 times x. Now let's do the subtraction. So yeah, so we've got minus x squared from there as well. That's minus x squared, and we have plus 3 here. We have 0x in the middle. Now what do you multiply x squared by to get minus x squared? You multiply it by minus 1. Minus 1 into this thing, that gives us minus x squared plus 0x or minus 0x. It doesn't make any difference. Minus 3. Okay, now change the signs again. It becomes plus, minus, plus. This gets cancelled. This also gets cancelled. And we're just left with 6 at the end. So we say we have to write down the quotient and remainder, right? So what's the quotient? Quotient is going to be 2x minus 1, and the remainder is going to be 6. That's what you had to do in the first part. Pretty straightforward. Now the second part says use it. Yes.
Sir, I wanted to ask, when we subtract minus x square from minus 0x square, won't we get positive x square?
Minus x squared minus 0x squared, that is minus x squared. This is being subtracted from minus x squared. That's minus x squared. The sign of this number is going to change, not the number on the top. Minus x squared comes down as it is. Okay?
Okay, sir. Okay.
All right, now we've got the quotient and the remainder. Now it says, use the answer to part A to find the exact value of this integral. Now, how do you do this? It's an improper integral. We know in order to integrate improper fractions, it's an improper fraction, sorry. In order to integrate improper fractions, we have to use that rule where we divide a fraction into two parts like this. We say this is dividend over divisor. Dividend over divisor can be split into two parts like this. Quotient plus remainder over divisor. And that's a standard method that we've got for integrating improper fractions. What's the quotient? We found the quotient to be 2x minus 1. So we say we've got 2x minus 1 plus remainder. Remainder is 6 over the divisor. Divisor is x squared plus 3. Now just integrate both of these parts separately, integrate 2x minus 1 separately, integrate this fraction separately, and input those limits. The limits are from 1 to 3. We'll do that at the end. Let's integrate them first. 2x minus 1, how do you integrate this? Integration of 2x is 2x squared over 2. Integration of minus 1 is minus x plus. You need to integrate this fraction now. What form is this? This is the tan inverse form, right? We've got a constant in the numerator. In the denominator, we have two terms. One is square term, and the other is a constant term. There's a plus sign in the middle. So it becomes 1 over x squared plus a squared form. Integral of that is 1 over a into tan inverse of x over a. All we have to do is, if we want, we can write 6 outside. And then inside, we would be left with 1 over x squared plus 3 squared. 3 x squared plus 3. 3 can be written as under root 3 whole squared, right? And now if you compare the two forms, in place of a, you've got under root 3. And you can apply that rule now, the tan inverse rule. You get x squared minus x outside. We have plus 6. Now, integration of this thing is going to be 1 over a into tan inverse of x over a. 1 over a, that means 1 over under root 3 into tan inverse of x over under root 3. That's the integration that we get for this. Now, once we've got the integral, now we can input the limits, or in fact, maybe let's simplify this further first. Just do one more step, x squared minus x plus 6 over under root 3. Just put this on your calculator. Your calculator will do the simplification for you. When I put this on my calculator, 6 over under root 3, that's giving me 2 under root 3. So this is 2 under root 3 into tan inverse of x over under root of 3. Now let's input the limits. Limits are supposed to be from 1 to 3. Let's input those limits. Let's input 3 first of all. When we input 3, we get 3 squared minus 3 plus 2 under root 3 into tan inverse of 3 over under root 3. Subtract from this the case when you input x equal to 1. That gives you 1 squared minus 1 plus 2 under root 3 into tan inverse of 1 over under root 3. Now, since we want an exact value, we have to show working for this. We can't just put this whole thing on our calculator and write down the final result. That is not allowed. Okay, so you have to show working. Now, do this separately. So 9 minus 3 plus 2 under root 3. You have to write down the result that you get from this expression first. Okay, put this on your calculator. You can do that. But show the result that you're getting for this expression. Tan inverse of 3 over under root 3. That's the same thing as tan inverse of under root 3. And that is giving me pi over 3. So this is pi over 3. This thing minus 1 minus 1, they get cancelled, right? And we have minus 2 under root 3 into tan inverse of 1 over under root 3. Now, what's that? Tan inverse of 1 over under root 3? That is pi over 6. So we've got pi over 6 here. This is the result that we get. Now we can simplify this further. 9 minus 3 is 6. And again, put this thing on your calculator. 2 under root 3 over 3 minus 2 under root 3 over 6. Okay, put this on your calculator and see what that gives you in exact form. 2 under root 3 divided by 3 minus 2 under root 3 divided by 6. And that is giving me under root 3 over 3 as the result of this. So we have under root 3 over 3 times pi. Right? Pi is also there. That's the exact integral that we get from this. 6 plus under root 3 over 3 times r. Okay, and that's our final answer. This is what we were looking for. Okay, not that difficult. You just have to remember that improper integrals are evaluated like this. We split them into two parts like this: quotient plus remainder over divisor. And that's the result that we get from this. Now let's move on to the next part. Now it says, okay, next question, in fact, question number 6. Now this looks iteration. Okay, that's the first part. We'll come to it. The second part is just about proving that root lies within that between that interval. Then you have this iterative formula. Okay, so the first part is what you're confused about in this question. Let's do the first part, and then I'll skip the rest of it because the other two parts are pretty straightforward. Let's try this now. What does this become? So you have to show that x satisfies this equation. Let's have a look at the diagram that we're given. It says the diagram shows a circle with center O and radius I. The tangents to the circle at the points A and B meet at T, and the angle AOB is 2x radians. The shaded region is bounded by the tangents AT and BT and by the minor arc AB. Okay, now all of this information is shown on the diagram as well. The only new thing here is that it says the area of the shaded region is equal to the area of the circle. Okay, so you have to find the area of the shaded region, equate that to the area of the circle, and that is going to itself give you this equation: tan x equals pi plus x. You will get that form from that somehow. Now let's try this. Area of the shaded region is equal to the area of the circle. Area of the circle is straightforward. That's just pi r square, right? The radius is r, so area of the circle is pi r square. We can figure that out. The problem is, how do you find the area of the shaded region? So how would you describe this shaded region? You can say you can find the area of this kite, okay, and then subtract from that area of the sector. Okay, that's one possibility. Or you can break it down into two parts, since some of you would not know how to find the area of the kite directly. This is the other possibility. Area of a kite is, by the way, half into d1 into d2. Half multiplied by d1 multiplied by d2. d1 and d2 are the two diagonals of that kite. So basically these two lines, this line and this line. But it's easier to just split it into two parts and find the areas of the rectangles instead. So that's what we're going to do here. We say, let's break it down into two parts. And let's just find the area of one of these triangles. And then we would just multiply that by 2 to find the area of the kite. Okay. Let's find that. Area of kite. Area of the figure. Let's find the area of the triangle first. OAT. What would that be? If this angle is 2x, we know that this angle is going to be half of that. That's a property of circle. Tangents coming from outside the circle. These angles are bisected like this. This angle is going to be x. So in this triangle, what do you know now? You know one side and you know this length x. It's a right angle triangle. One possible formula that you can use for the area of the triangle is half into base into height. You've got one of those sides. You can find the other side. How? How do you find this side? Which ratio do we use for that? This is perpendicular. This is base. Perpendicular and base, they're connected by tan. So we can say tan of x equals perpendicular, which is 80, divided by base, which is r. So 80 equals r tan of x. That's the length 80. So can we find the area of this triangle now? Because we know this length is now r tan x. It's going to be half into base into height. So that's half into r tan x. What do we get from that? Half r squared into tan of x. This is the area of the triangle. Now, once we know the area of the triangle, we can also find the area of that whole figure, area of the kite. What's the area of the kite now? Just multiply this by 2. 2 into this. That will be r squared tan x. Right? I just multiply this by 2. This is what we get. So we've got the area of the kite. Subtract from the area of the kite the area of the sector. And that will give you the shaded area. Let's see what that turns out to be. Shaded area is area of sector. Sorry, area of the kite minus the area of that sector. We've got the area of the kite, that is r squared tan x. Subtract from that the area of that sector. What's the area of the sector? The formula for that is half r squared theta. Radius is r, so that's half r squared into angle. Angle is 2 times x. This whole angle is 2 times x. So r squared into 2x. Let's simplify this. We get r squared tan x minus r squared x. Now this is the shaded area. Now they said the area of the shaded region is equal to the area of the circle. What that means is this area should equal pi r squared. Now r squared is appearing in every single term. We can take that common and cancel that out. We would just be left with pi equal to tan x minus x. And what do you have to do now? You have to make tan x the subject. And that gives you tan of x equal to pi plus x. That's what you had to do in the first part here. Not that complicated. It's some working for 3 marks, but not that complicated, right? A simple circular measure problem. And circular measure comes a lot in paper 3 and iteration questions. So you need to make sure that you understand that very well. And sometimes these questions are kind of complicated as well. Okay, so that's the first part. Now in the second part, it says this equation has one root in this interval. You just take everything to one side, and then you input 1 inside that and 1.4 inside that. One of those values will be negative, the other will be positive, and you would say since the sign is changing, a root lies within that interval. All right, so that part, this part is pretty straightforward. And then the next one says use an iterative formula, or in fact, use this iterative formula to basically find that value. Again, pretty straightforward. I'm going to move on to the next one. Okay, so what other problem do you have from this paper? Let's have a look at the next one now. Okay, question number 7. Show that the derivative is less than 0 for all x in this interval. Okay. All right, let's have a look at this as well. Question number 7. It says we've got this function. Question number 8. Okay. We'll do that as well. Let's see if this is any complicated. It does not look very complicated, by the way. The second part, at least. First part is something that you will need to think about a little. So I'll do the first part, and then we'll see if we can have a quick look at the second part as well after that. Question number 7, part A. Okay, let's try this. It says, let f of x equals cos of x over 1 plus sine x. So that f dash of x is less than 0. What is f dash of x? That's the derivative of f of x, right? How do you differentiate it? F dash of x, it's a fraction. We can apply the quotient rule in this. This is u, this is v. The derivative is given by vu dash minus uv dash divided by v squared. Now, in the denominator, we get 1 plus sine x whole squared. In the numerator, v comes as it is, that is 1 plus sine x multiplied by u dash, which is, what's the derivative of cos x? The derivative of cos is minus sine, so it becomes minus sine x. Subtract from this u as it is, that means cos of x as it is now, into derivative of 1 plus sine x. What will that be? Derivative of 1 is 0, derivative of sine is cos, so it becomes cos of x. This is what we get. Now let's simplify everything. Minus sine x minus sine square x minus cos square x. Right? This is what we get in the denominator. We have 1 plus sine x whole squared. Now let's keep it like this for now. And let's just think about the numerator first of all. What do we have in the numerator? Minus sine x minus sine square x minus cos square x. Now, can we simplify this a little? We can say this is minus sine x minus, if we take minus common, that leaves us with sine square x plus cos square x inside. And what's that? Sine square x plus cos square x is equal to 1. This thing becomes 1. Remember, the denominator is not 1. Okay, that's actually clearly not 1. But it's sine square plus cos square. That is 1. This becomes 1 now. We can write this as minus sine x minus 1 divided by 1 plus sine of x whole squared. We need to prove that no matter what the value of x is, this result is always going to be negative. What's the interval that we're given? The interval is from minus pi over 2 to 3 pi over 2. What's that interval? Well, think about this. minus pi over 2 is this, and then pi over 2, pi, 3 pi over 2. So basically it's one full circle, right? So it's going from minus pi over 2 to pi over 2. The cycle is completing. It's one full cycle for sine. Okay. And what is the value? What is the range of the sine function? It's from -1 to 1. If one full cycle is completing, we know that sine of x has to be between -1 and 1. It can't go outside this interval, right? You should know the graph of sine function as well. This is what the graph looks like. This is from minus pi over 2 to 3 pi over 2. That graph will be starting from here, maybe ending here. But again, the maximum value is 1 and the minimum value is 1. That's what you need to know about. Okay. Sine function goes from -1 to +1. Now, how do you prove that the derivative is less than 0 no matter what the value of x is? Let's think about this. We can say, if we take minus common, this is f dash of x, right? If we take minus common, that leaves us with 1 plus sine x inside. And then in the denominator, we've got 1 plus sine x whole squared. Now we can do some simplification here as well. 1 plus sine x and 1 power of 1 plus sine x in the denominator, that will get cancelled. And the derivative eventually is going to turn out to be this 1 over 1 plus sine x. Now think about this. We know that sine x is supposed to be between -1 and +1. Okay. And in fact, in this case, minus pi over 2 is not included. Minus pi over 2 is not included, although 0 is still included, so it can be 0. At minus pi over 2, it's going to be -1. Okay, let me ask you. So can somebody try this as well, actually? Minus pi over 2. What happens when you have minus pi over 2? It becomes -1, right? So sine of minus pi over 2 is -1. And also sine of 3 pi over 2 is also -1. Both of these points are not included. You don't have an equal to sign with them, right? If you had an equal to sign there as well, you would say it's going from -1 to 1. But since you don't have an equal to sign there, what that means is the -1 value is not included. So the interval actually just looks like this, from -1 to +1. 1 is included and -1 is not included if this is the interval for x. Okay, -1 is not included. Why is that important? Because if sine x becomes -1, this would become 1 over 1 minus 1, which is 0, -1 over 0, and that's undefined. Okay, so that's why -1 is not included here. Now, that said, if sine x is between -1 and 1, what about 1 plus sine x? What is that interval going to be? Let's add 1 to the whole inequality here. -1 plus 1, 1 plus sine x, and also 1 plus 1 here. So I've added 1 to the whole inequality. What does that give me? That gives me 1 plus sine x, that is between 0 and 2. 0 is not included and 2 is included. That means this denominator here has to be positive, right? 0 to 2, that means it's positive. Now, if this denominator is positive, we have a minus sign outside. The number inside is 1 over some positive value. So this whole thing is positive, but since we have a negative sign outside, that means f dash of x is actually going to be negative, right? Because of the negative sign outside, minus into some positive number, the whole thing becomes negative, right? So that proves that f dash of x is less than 0, no matter what the value of x is. Okay? Does this make sense? Any questions on this? Any confusion?
Sir, will we show this working, or can we
Yes,
write it
of course.
directly? Okay.
How do you write that directly? This is what you have to show. So you have to clearly explain how it is negative, right? So what would you write directly?
So like if I don't get the answer right, I can just write f dash of x is less than 0.
Well, that's given in the question. You have to show this. So it would not
Okay, sir.
be enough.
Okay.
It would not be enough. Okay. So you have to justify that statement. If it was not given and you had to prove that the function was increasing or decreasing, generally for questions like that, you get away with just writing this down without explaining much. But since it's already given in the question, it's the working that is going to be checked. So you need to make sure that you explain clearly, justify clearly why this is negative. Okay, now you don't have to write this in words. This is enough. So this working on the right side, this is not necessary. But what you would say is you have a negative. So I'll tell you what working is important. This step and this step. So basically you have a negative sign outside, and then you say outside you've got a negative sign, and then that's being multiplied by something positive. So the whole thing becomes negative, right? Negative into positive, that becomes negative, and that proves that the derivative is supposed to be less than 0. Okay, this is not necessary for you to show. You can just think about that in your head as well. Okay, now f of x, we need to integrate this and input those limits and give an answer in exact form. Now this is quite straightforward because the integral that we have to evaluate is cos x over 1 plus sine x, right? This is what you need to integrate. I'll just tell you how to integrate this. You should be able to clearly see which form this is. It's a fraction. It's the ln rule, because the derivative of the denominator is there in the numerator. 1 plus sine x, the derivative of that is cos x. So the integration of this is just going to be ln of 1 plus sine x, and then you just have to input the limits from pi over 6 to pi over 2 and write down the answer in exact form. Now, it's a simplified exact form. You need to make sure in your final answer, you have a single ln term. Do not write multiple ln terms in the final answer. You have to convert it to a single ln term. Okay, that will have 1 mark at the end. Just make sure that you do that. Applying the division law or the multiplication law, you can do that. Okay, so this is pretty straightforward. I'm sure you should be able to do that. Let's look at the next one now. Question number 8. Okay, so this is the next one that we have. This is what you're saying is slightly complicated. Okay, let's try this now. It says a certain curve is such that its gradient at a point xy is proportional to y over x under root x. The curve passes through the points with coordinates 1, 1, and 4e. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. Now, how do we think about this? What are we given? A certain curve is such that its gradient at a point xy is proportional to y over x over under root x. Now, if it's a curve, if it's a function that's y in terms of x, how do you write down the gradient of that function? How do you find gradient of a curve? That's dy over dx, right? Gradient of a curve is written as dy over dx. Now it says it's proportional to y over x under root x. That means that it equals k times y over x under root x. That is what your differential equation is going to look like. Okay, quite straightforward. And now what you need to do is, you have 2 points given on the curve, 1, 1, and 4e. You can use them to find the value of this k and also the value of the constant that you would get after integrating. Now, since you don't have a value for dy over dx at any point, you can't find k right now. You first have to solve the differential equation, and then after that, you can find the value of k along with the value of c. So let's solve this differential equation first of all. How do you do that? The first thing you have to do is you have to separate the variables. Let's separate the variables. Y terms on the left side, so we can take this y to the left. It becomes 1 over y into dy on the left side. Take dx to the right, and it becomes k over x into under root x. I'm going to write it like this: x raised to power 1 into x raised to power 1 over 2. What does that become? X raised to power 1 plus 1 over 2. That's x raised to the power 3 over 2. And then we have dx here. All right. And now we can just integrate both sides because the variables are separated now. How do you integrate 1 over y? Integration of 1 over y is ln y. How do you integrate this thing? You can basically bring x to the numerator. It becomes kx raised to the power minus 3 over 2. And now you can apply the power rule on this. K remains as it is because k is a constant. You add 1 to the power minus 3 over 2 plus 1. That becomes minus 1 over 2. Divide by that new power, divide by minus 1 over 2. And you have a plus 3 with that. And that's your integration done. Okay. Now remember, you can't use power rule on the left side here because if you were to bring y to the numerator, it would become y raised to power minus 1. You can't use power rule on that because if you try doing that, it becomes y raised to power minus 1 plus 1, which is y raised to power 0 over 0, which is undefined. So when you have when you have something raised to power minus 1, power rule does not work on that. You have to use the ln rule for that, right? By writing this as a fraction. So this becomes this becomes ln y. Integration of the left hand side. Now that we have integrated this, now let's find the values of k and c. How would we do that? ln y equals, this 2 will go to the numerator. So it becomes minus 2k into x raised to the power minus 1 over 2 plus c. Now we can simplify this a bit further. It becomes minus 2k divided by x power 1 over 2 plus c, or under root x if you want to write it that way. Now let's input these points. 1, 1. This is 1 point that we're given. We can input that here in this equation. Put 0.11. 1, 1 means when x is 1, y is supposed to be 1. What do we get from that? We get ln of 1 equal to minus 2 times k divided by 1 raised to the power 1 over 2 plus c. ln 1 is 0. On the right side, we've got minus 2k plus c. We get one equation in terms of c and k, that is c equals 2k. Since there are two unknowns, we need another equation as well in terms of c and k. Now for that, what we can do is we can input the other point. The other point is 4 and e. Let's put that point here as well inside this equation. In place of y, input e, so it becomes ln e. On the other side, you have minus 2k divided by 4 raised to the power 1 over 2 plus c. ln e is 1, right? On the right side, you have minus 2k over 4 raised to the power 1 over 2. What's that? That's just 2 plus c. So you get 1 equals minus k plus c, and the value of c turns out to be k plus 1. Now you just solve them simultaneously. That gives you 2k equals k plus 1, and the value of k turns out to be equal to 1. What's c then? C is 2 times k, so c is going to be 2. We've got the values of c and k now. Once we've got the values of c and k, we needed to write the equation of the curve expressing y in terms of x. Let's write that down. Okay, we have some space here. Now let's put that back. The values of k and c, the equation becomes ln y equals minus 2 into 1, that's just minus 2, divided by x raised to the power 1 over 2 plus c, which is plus 2. That's the equation that we have now. Now we need to make y the subject. How do we make y the subject? It's ln y. What's the base of ln? The base of ln is e. E will go to the other side, become the base of this whole thing. So you get y equals e raised to the power minus 2 over x raised to the power 1 over 2 plus 2. Or you can also write it like this. You could say it's e raised to the power minus 2x raised to the power minus 1 over 2 plus 2. That is y in terms of x. That is what we were looking for in this part. Okay, the base of ln is e, so that e goes to the other side, becomes the base of whatever you have on the right side. Makes sense? Now let's move on to the next part. Now the next part says, describe what happens to y as x tends to infinity. Let's think about this. We've got y in terms of x now. Y equals e raised to the power minus 2x raised to the power minus 1 over 2 plus 2. Now, since they don't want an exact answer, you could use a calculator for this as well. Now, first of all, let me explain this to you logically, which you should know as well, because sometimes they want exact answers. In that case, you have to think like this. So let me explain it this way first. So when x becomes very large, when x goes towards infinity, just focus on the part that has x. This is the part that has x, right? X raised to the power minus 1/2. Let's focus on that. As x goes towards infinity, what happens to x raised to the power minus 1/2? X raised to the power minus 1/2 is the same thing as saying 1 over x raised to the power 1/2. So in the denominator, you have something extremely big. 1 over an extremely large number, what does that become? This becomes 0. So as x goes to infinity, what happens is this thing becomes 0. If that becomes 0, what happens to y? Y is equal to e raised to the power minus 2 into 0 plus 2, and that gives you y equals e squared. This is the value of y that you get when x goes towards infinity. Okay, this is one way of figuring this out. You will have to do this if you want an exact answer. Sometimes they ask you for exact answers as well. Now, in this case, they have not specified that they want an exact answer. So you can write down this value in decimal as well if you want. How would you do that? You would put a large number on your calculator. So you'll do something like this. Let me open this quickly. So on your calculator, you'll do something like this. Just put this function. That's e raised to the power minus 2 into x. In place of x, put a large number, any large number. So let's say 9999, for instance. Raised to the power minus 1/2, that's minus 0.5, plus 2. Just put this on your calculator like this, and your calculator is giving you an answer 7.243. You can just write that as it is as well. Okay, e squared is going to be the same as this. Let me show that to you. This is 7.243, right? Well, no, it's slightly different. Maybe we needed to put a larger value than that. This is 7.389. Okay, let me go to that again. And no, I have to input that again. E raised to the power minus 2 into x, which has to be some large value. Let's actually put a larger value. Raised to the power minus 0.5 plus 2. And that gives us 7.389. That's very close to e squared, basically. E squared is this number, right? 389. So you could do it that way as well, and that will also be acceptable as long as they are not asking you for an exact answer. If they asked you for an exact answer, then this is what you have to do, what we did here. Okay, otherwise you could use a calculator like this as well. Okay, and put a large number in place of x, and you will get a result from that. Make sense? Any problem with this? Any questions, anyone?
No, sir.
Okay, let's move on now. Prove that this is a right angle. You can use the dot product of AB and BC. That will turn out to be 0. Show that this triangle is isosceles. Just find two lengths and they will be equal. It's a right angle, right? It's a right angle triangle. You find the length AB and BC. They will turn out to be equal. And then exact length of the perpendicular from O to the line BC. See, it's a standard vectors question, nothing new. If you have done vectors well, understood the concepts that you need to know for that, this is a standard question. You see how many times this exact thing is repeating in the few papers that we have done until now. It keeps coming again and keep coming again and again. So you need to make sure that you remember the exact steps that you have to follow for that, right? And then you just have to use them and you get the result. That's pretty straightforward. Okay, this is question number 10, complex numbers. Let me look at the poll again. Did anyone ask about this? No one? Okay. So we have done these types of questions a lot of times before, but let's actually do this question. It looks slightly tricky. Let me do this as well. This is the last question from this paper, question number 10. Let's have a look at this now. And then please make sure that you have voted for the other paper as well, the questions that you find differently from the other paper. So we can quickly move on to the other paper as well after this and do the difficult questions from that paper as well. Okay. All right. The complex number u is defined by this, where a is real. Express u in Cartesian forms. The first part, you have one complex number divided by another complex number, multiply and divide by the conjugate. So you multiply by a minus 2 iota and also divide by a minus 2 iota. Now let's simplify the whole thing. It becomes 3a iota minus 6 iota squared. In the denominator, it's a plus b into a minus b. So that's a squared minus 2 iota whole squared. Let's simplify this further. It becomes 3a iota minus 6 into minus 1. A squared minus 2 squared is 4 into iota squared is minus 1. And that becomes 3a iota plus 6 divided by a squared plus 4. Now you need to write this in the form x plus y iota. Generally, what you should do is write this, write the two terms separately. Real part separate, imaginary part separate. Now, in this case, what's the real part? Real part is where you do not have iota. So that will be 6. Split this fraction into two parts, write the real part first. That becomes 6 over a squared plus 4. And then the imaginary part, that is 3a over a squared plus 4 iota. This is what u turns out to be. U equals this. Okay. Now it says, find the exact value of a for which the argument of u conjugate is pi over 3. Okay, now we need to find the value of a for which the argument of u conjugate. Now, what is u conjugate going to be? This is u. What's u conjugate? U conjugate is going to be 6 over a squared plus 4 minus 3a over a squared plus 4. This is u conjugate. Now, first of all, you should figure out which quadrant this is going to be in. Okay, which quadrant is this going to be in? Let's think about it. Real part is positive. A squared is always going to be something positive. Real part is positive. Imaginary part is turning out to be negative here. Let me just look at this again as well. Does that say anything about A? Okay, so we know that u conjugate, the argument of that is pi over 3. If it's pi over 3, that's 60 degrees. It should be in the first quadrant, actually. So let me do this. If this is u conjugate, the angle is pi over 3. Which quadrant should it be in? Which quadrant should it be in? It should be, so just let me put this on silence. Okay. Which quadrant should it be in? It should be in the first quadrant because the argument is pi over 3, that's 60 degrees. It's going to be like this. Now, let's suppose u conjugate is here. This is u conjugate. And the angle is pi over 3. What does that mean? That means the real part here, what's that? That is 6 over a squared plus 4. That's the real part. And this is the imaginary part. Imaginary part here is supposed to be minus 3a over a square plus 4. Now you see this is minus 3a. This whole thing is the imaginary part. There was iota there as well. This whole thing is the imaginary part. Now, how can this be negative? Well, for this point to be here in the first quadrant, imaginary part has to be positive. Since the imaginary part has to be positive, we have a negative sign here. That means the value of a that we get at the end, that has to be something negative. So that negative into negative, that makes it positive. Okay, but you'll understand that when we actually do the steps for this. We've got the real part here. This is the real part. This is the imaginary part, right? I've just marked them on the figure and represented that the angle is pi over 3. Now think about this. This is perpendicular and this is the base. We know the angle. What's the ratio between perpendicular and base? That's tan. We can say tan of pi over 3, that should equal perpendicular, which is minus 3a over a square plus 4 whole divided by 6 over a square plus 4. Perpendicular over base, that's all that we're doing here. Okay, now what is tan pi over 3? You can evaluate this on your calculator and see what that gives you. Make sure your calculator is in radian mode. It's not tan inverse, it's tan. Tan of pi over 3, that is giving me under root 3. So on the left side, I get under root 3. On the right side, a square plus 4 and a square plus 4, they get cancelled. And we have minus 3a over 6. Now, these also get cancelled. 3 gets cancelled with 6. You've got 2 left here. And the value of a turns out to be minus 2 under root 3. That is what we were looking for. A equals minus 2 under root 3. Okay, that's the second part of this. Slightly tricky, different from the usual questions that you get. So this is how you would think about this. You know the argument, just represent that on an argument diagram to try to understand that better. It's a right angle triangle. Use the tan ratio, and that gives you the result. Okay, now let's move on. Let's look at the next one. It says, on a sketch of an argument diagram, shade this region whose points represent the complex numbers satisfying both of these inequalities. Let's do this quickly as well. We've done a lot of questions like this before already, so I'll be quick about it. So this is what the argument diagram would look like. Let's look at the first inequality first of all. They're talking about 2 points. First of all, convert it to standard form. What is the standard form going to be? Make some space there. Okay. What's the standard form going to be? We need to take minus common. So minus is already there in the first modulus. On the right side, if you take minus common, that leaves you with 1 plus iota inside. So what we are saying is, distance of z from 2 iota, that has to be less than or equal to the distance of z from 1 plus iota. We're talking about distance from 2 points. Okay, distance from 2 points. What's that locus going to be like? It's a perpendicular bisector. So first of all, let's label these axes, or mark the numbers on these axes. 1, 1. Make sure you're using the same scale on both axes, x and y. 2, 3, 4. And on the left side, you've got minus 2, minus 3. On the right, you've got 2, 3. And here you have minus 2 and so on. Let's mark those 2 points first of all. One point is 2 iota. Where is that point going to be? Right here on the vertical axis. Okay. Then the other point is 1 plus iota. Where is that point? 1 on the right and 1 up. That is going to be this point here. You have to draw perpendicular bisector of this. Okay. Now you can use a compass for that if you want, or you can Do it like this. Find the midpoint of this line. That will be this. And just make a perpendicular from this. Now, when you make a perpendicular line here, you have to be careful. You see, this gradient is -1. You can see that here. The gradient of this line is -1. So when you take perpendicular of that, the gradient of that line is going to be negative reciprocal of this, which is 1. So that line is going to be of gradient 1, the perpendicular that you draw here. That is going to pass through this point 1 here. And then of gradient 1, that means it goes to these points. That is important. If you don't take care of this, the next parts are going to become difficult for you. So if you have a calculation part after a locus diagram, make sure your diagram is very accurate. Otherwise, you will have trouble understanding the next part. You're not going to measure anything for the next part, but if you have a good diagram in the first part, that really helps with your calculation in the next part. Okay, so make sure your points are your perpendicular bisector is passing through these points. That is important. Now, let me draw this perpendicular bisector. This is what it looks like. I'll just correct that. It has to pass through all of these points like this. This is your perpendicular bisector of those 2 points. Now, what does the inequality say? The inequality says distance from 2 iota should be less as compared to the distance from 1 plus iota. So the point has to be closer to 2 iota and far away from 1 plus iota. So which side should be shaded? The side that has 2 iota. This is the point 2 iota. This is the side that you would be shading. Okay. But now we have another condition as well. Let's think about that condition. What's that? Z minus, again, convert this to standard form as well. Z minus 2 plus iota, modulus of that is less than or equal to. This is 1 point. And on the other side, you've got a constant. What is the locus of an inequality like this going to look like? It's a circle. What's the center of the circle? This is the center of the circle. This is the radius of the circle. The center is at 2 plus iota. That point is going to be here. 2 plus iota. You need to make a circle of radius 2 here. Sorry about that. Circle of radius 2. Let's see what it looks like. Center at that point, 2, 1. Now, again, you have to be careful about this circle. If the radius is 2, what that means is, if the center is at 2 plus iota, on the left side, this circle should just be touching the y-axis. On the lower side, it should be going up to -1. On the right side, it should be going up to 4. So let's say 4 is here. This is 4. And above, it should be going up to 3. Okay, you have to take care of this thing. This is what the circle is going to look like. You will use a compass for this. Make sure your diagram is drawn with the same scale in both axes. You should get something like this. Okay. Now you have to be inside this circle and above that perpendicular bisector. Which region satisfies both of these conditions? It's this small region here. Above the perpendicular bisector and inside the circle, because the radius is less than the distance from that point is less than equal to 2. You have to be inside the circle and above the perpendicular bisector. This is the region that satisfies both of those conditions, and that's what you would be shading there. Okay, that's your final result from this. Okay. Now let's move on to the next part. Now it says calculate the least value of argument of z for points in this region. When do you draw dotted lines? Well, if it was if you did not have an equality sign here, if it was less than this, then you would draw dotted lines for the perpendicular bisector. If you had less than sign here only, you could draw dashed lines for the circumference of the circle as well. But in A levels, it's not necessary. Even if it's less than or less than equal to, you can just draw solid lines. That's also acceptable. Although doing that is better, drawing that dotted is better if you have strict inequalities. But they don't deduct marks for this generally. Okay, now calculate the least value of argument of z for points in this region. Now these are the points that we have in this region, the shaded region on the diagram. Now we need to find the least argument for points in this region. Now, how can we find the least argument? Where is argument measured from? From the origin generally, right? So we have a line from origin. We go like this. Okay, let's keep increasing the argument. When do we first touch that shaded part? Let's keep taking it upwards. Let me actually enlarge it a bit. When do we first touch that shaded part? I'm increasing the angle, right? This is where we first come in contact with that shaded part, this point here. This is the least argument that we are looking for. Now, how do we find that least argument? The point is we need to figure out what this point is. How do we know what this point is? This point is the point of intersection of that perpendicular bisector and that circle. We know that the highest point of the circle here was 3. And the line that we drew, it had an angle of 45 degrees, right? It was perpendicular bisector. It was gradient 1 line. We talked about this when we were drawing this line. So this line is passing through this point as well. This point is 2 plus 3 iota. It's not a guess from the sketch. It's an inference from the gradient of the line and the maximum point of the circle. You would only be able to figure this out if you have drawn your diagram reasonably well. Otherwise, you would not be able to figure this out. Okay? And then you'll spend time calculating the point of intersection of the line and the circle. That's not required here because it's obvious from here that the point that we're talking about is 2 plus 3 iota. Now, you just have to find this angle now. You know that the perpendicular is 3. This height is 3. Base is 2. You can just use tan for this, and you would say, if that angle is theta, tan theta equals perpendicular, which is 3 divided by the base. That's going to give you the argument. You can see what that turns out to be. Tan inverse of 1.5. And that is giving me 0.983. That's the least argument for points in this region. Okay? And that's the second part of this question. B2 of this question. Okay? I hope that makes sense. Yeah, exactly. That's correct for me. Okay, so this is what we get. This was the least argument. Okay, that's a good question. So you're asking if you do any other working on this diagram, do you get full marks for the first part? Well, yes, as long as what you did for the first part is clearly visible still. If that is not visible, then you'd have a problem. In this case, it's visible. We had to shade that correct point, and we have done that. Since that is visible, this is all right. But if you mess the diagram up a lot, so that what you did in the first part is not clear, then you can lose marks on that as well. Okay. All right. So that's it from this paper. Let's have a look at the next paper now. That's June 2020, paper 3, variant 3. Let's have a look at some questions from that paper too. Okay, please submit your response to the poll quickly as well if you haven't already, so I can decide which question to do from this paper. June 2020, paper 3, variant 3. This is the next one that we're doing now. So I'll just take a 1-minute break. Ask you to submit that poll quickly, please. Okay, let's start with this one now. June 2020, paper 3, variant 3. Well, it looks like an easier paper, to be honest. Let's start to look at the questions quickly. Maybe question number 10 might be tricky. The diagram looks a bit tricky. But apart from that, it does not look that difficult. Okay, so let's have a look at some questions from this paper as well now. June 2020, paper 3, variant 3. Okay, so I see some responses to the poll. I'll go through the questions quickly. This is an easy modulus inequality question. For this, you will just use integration by parts to integrate and put the limits. Simple log problem. Okay, some of you have asked about question number 4. Let's start with this one. Find dy by dx first of all. Now it's a product, so remember you have to differentiate it using the product rule. What's dy by dx going to be? You can say this is u and this is v. The derivative is given by uv dash plus vu dash. dy over dx. U as it is, that means x as it is. What's the derivative of tan inverse of half x? Derivative of tan inverse of x is 1 over 1 plus x squared. But if you have something other than x here, what does that mean? Whatever that thing is, you have to multiply by the derivative of that as well, right? That's the rule that we've got for tan inverse, for differentiating tan inverse. Okay, so what's v dash then? Derivative of this thing, that's going to be 1 over 1 plus half x squared multiplied by derivative of half x. What's that? That's half. That's uv dash plus v as it is, and the derivative of u. V is tan inverse of half x into derivative of x, which is just 1. Now let's simplify this. You have x, this 2, I can just write that outside to make things simpler. So I've got 1 over 2 times x into 1 over 1 plus x squared over 4 plus tan inverse of half x. This is the derivative. Now, you can leave it like this as well, I suppose, because they have not really asked you to simplify this, but it's better to simplify anyway. How would you simplify it? In the denominator here, you can take LCM, and it would become half x into 1 over 4 plus x squared divided by 4 plus tan inverse of half x. And then you can do some cancellation. Remember, these 4 cannot be cancelled. Please don't do that. 4 and 2, they get cancelled. You have 2 left here. This 2 now goes to the numerator. And the final result, simplified form, turns out to be 2x, because of this x as well. This 2 goes up, and you have 2x there, over x squared plus 4 plus tan inverse of half x. That is dy over dx. That is what we were looking for in the first part. Okay. Now it says the tangent to the curve at the point where x equals 2 meets the y-axis at the point with these coordinates. Find the value of p. So basically, you have to find the y-intercept of the tangent to the curve at that point. How do you find the equation of a tangent? For finding the y-intercept, we need the equation of the tangent first of all. We need 2 things for that: a point and the gradient of that tangent. How do you find the gradient of the tangent? You've got the derivative already. Put that value of x there, x equals 2. Let's input that here and see what that gives you. When x equals 2, dy over dx is 2 into 2 divided by x squared. That means 2 squared plus 4 plus tan inverse of 2 over 2, which is just 1. Simplify this and see what that gives you. 4 over 8, right? That's 1 over 2. Plus tan inverse of 1, that is pi over 4, right? 1 over 2 plus pi over 4. This is the gradient of that line. Now, they don't want an exact answer as such. So what you can do is you can write this in decimals as well if you want. The gradient turns out to be, or let's just leave it like this for now, 1 over 2 plus pi over 4. That's the gradient. This is the gradient of the tangent. Now, we also need a point. X value is 2. How do you find the corresponding y value of this point? This is the equation: y equals x into tan inverse of half x. Y equals 2 into tan inverse of half x. That means half into 2, that's 2 over 2. And that's going to give you 2 pi over 4, which is pi over 2. So the point that you have is 2 and pi over 2. Now you've got a point, you've got the gradient, you can write down the equation. What does the equation look like? Y minus y1, that means y minus pi over 2 in equals m, which is 1 over 2 plus pi over 4 whole multiplied by x minus 2. Okay, that is the equation of the tangent. Now, what were we looking for? We were looking for the y-intercept, right? Where the point where the tangent meets the y-axis. How do you find the y-intercept of a line? For finding the y-intercept of a line, what you have to do is you have to put x equal to 0. So that's what we do here. We put x equal to 0. Let's see what we get from that. When we put x equal to 0, that gives us y minus pi over 2 equals 1 over 2 plus pi over 4 whole multiplied by minus 2. And y equals minus 1 minus 2 pi over 4, that's minus pi over 2, plus pi over 2 from the other side, and the y value becomes minus 1. They said the y-intercept is p. So we can say the value of p therefore equals -1, right? That's what we were looking for. The value of p turns out to be -1. So we just find the equation of tangent. Put x equal to 0 to find the y-intercept. They said the y-intercept is supposed to be p, and we got that y-intercept there. Okay, I hope that makes sense. Let's move on to the next one now. Okay, so what's the next one that we want to learn? So we're done with question number 4 now. Okay, so no one has asked about 5. Should be doable. Just apply the compound angle identity for tan, and then write this thing as you can either write this as 1 over tan or cos. Okay, you want an equation in terms of tan, then you should do this. You should keep it in terms of tan. So 2 over tan 2 theta. Then apply the double angle identity for tan here, and then simplify everything. You get a quadratic equation. Then you can solve that. Got a lot of space for that. Question number 6, just have to draw these graphs and then iterative formula and so on. For drawing these graphs, all you have to do is use the table function on your calculator. Now, in this case, the problem is they have not given you an interval. Okay, when you have something like this, when the interval is not given, what you do is you take points close to 0. So take an interval like this. Now, you don't have to do this manually on your calculator. Put f of x equals x raised to the power 5. And then the other function, if you have g of x as well in your table function, g of x equals 2 plus x. In fact, that's just a straight line. You don't really need to do that necessarily. You just take 2 points manually for that. For x raised to the power 5, you can maybe start your table from -5 and add 5 and take a step of 1. You will get some points and you can draw a sketch using that. I think it's going to look something like this. X power 5 graph. Okay. But just take some points, join them, you'll get the graph. Okay. Then you have to write down that there's only one point of intersection. That is why there is one solution. Okay. So I expect you to be able to do that. Okay. What's the problem with 6b? It says, show that if a sequence of values given by this iterative formula converges, then it converges to the root of the equation in part A. Now, it's a standard iteration question. What you do in such problems is, the main problem is understanding what the question statement is basically telling you. It says, if this iterative formula converges. Converges means if it becomes stable at some value. Remember, when you use iteration, the value eventually gets stable. That's also called convergence, that the value converges to something. So what they mean by this is, if this gives you a solution, if this iterative formula gives you a solution, then that solution is the root of the equation that you have in part A. That means the solution that you would get, the answer that you would get from this iterative formula actually is the answer to this equation. So what you have to do is, you have to prove that this iterative formula corresponds to that equation. It's coming from that equation. Now, you can either convert this equation to this form. Generally, it's easier to do it the other way around, that you convert the iterative formula to this form and prove that it's coming from that equation. How would you do that? You would just remove the n plus 1 and n signs from this. X equals 4x raised to the power 5 plus 2 divided by 5x raised to the power 4 minus 1. Now just rearrange it and show that this can be written like this. Multiply this on the other side, and that will give you 5x raised to the power 5 minus x equals 4x raised to the power 5 plus 2. Take x raised to the power 5 term to the left side. That gives you x raised to the power 5 equals x plus 2. That's all that you had to do Since it says 2 plus x, you can write this in the other order if you want. It doesn't make much difference though. X raised to the power 5 equals 2 plus x. That means this formula, this iterative formula is coming from that equation. So that means whatever solution this formula gives you, it has to be solution of this equation because this iterative formula is coming from that equation. Okay. Then you use this iterative formula in the next part to find those values. If you do that, making sure that you take care of the accuracy level that's given in the question, because if you don't follow this, you lose marks. These are free marks in paper 3. You cannot afford losing any mark, a single mark in these parts. Okay. Otherwise, it's going to be very difficult to get a good grade. Okay, so the next one is question number 7. It's not that difficult. In the first part, you do partial fractions, and then in the next part, you have to show that f of x whole squared becomes this. How would you do that? When you have partial fractions, you will have a over, you get something like this, a over 2x minus 1 plus b over 2x plus 1. When you square this thing, when you square this whole thing, you would get a squared, that's going to be square of this term, plus b squared, that's going to be square of this term. That's these two terms. Plus 2 into this. Let me actually do this for you because you might get confused with these two terms in the middle. What do the partial fractions turn out to be for this? Let's assume that you're done with that part. Does somebody have the values of a and b from this? From the first part? What are the values of a and b from the first part? Anyone check the marking scheme for this? Let me see
Sir, it's 1 and minus 1.
1 and minus 1? Okay, 1 and minus 1.
A is 1 and B is minus 1.
All right, so these are 1 and minus 1. We have marked. Now we need to expand, we need to square that thing and prove that that becomes this. Let's see how we can do that. F of x whole squared, what would that be? 1 over 2x minus 1 whole squared plus or minus, since there's a minus sign here, we could say this is like this. Minus 2 into 1 over 2x minus 1 into 1 over 2x plus 1 plus b squared, which is 1 over 2x plus 1 whole squared. Right, that's what you get when you square this. Now, the first term becomes 1 over 2x minus 1 whole squared because square of 1 is just 1. In the denominator, we have 2x minus 1 whole squared. And then we have minus 2 over 2x minus 1 into 2x plus 1. And then you have plus 1 over 2x plus 1 whole squared. And now if you notice, this is the same thing that you had here. You already know that this can be split into two parts like this. Okay. So you split that into two parts as well. What does that become? 1 over 2x minus 1 whole squared minus outside, leave that as it is. This becomes 1 over 2x minus 1 minus 1 over 2x plus 1 plus 1 over 2x plus 1 whole squared outside as it is. Simplify this and that gives you 1 over 2x minus 1 whole squared minus 1 over 2x minus 1 plus 1 over 2x plus 1 plus 1 over 2x plus 1 whole squared. All right, so that's how you do the second part. Okay, now in the third part, they just ask you to integrate this, input these limits, and prove that this becomes this. Now, again, no one has asked about this, so I'm going to assume that you can do that. You just have to integrate these terms now. The first one will be done using power rule. You will say this is 2x minus 1 whole power minus 2. Apply power rule on this. This is log rule. This is again log rule, ln rule, right? In both of them. And then on the last one as well, again, you use the power rule. It becomes 2x plus 1 whole power minus 2. You integrate it like this. The middle one will be integrated using ln rule. Okay. Then you just integrate them, input the limits. You can prove that thing. Okay. So try this again. Since you guys have not asked about it, I'm just going to move on. The next one is question number 8. Okay. This actually does not look that difficult. Relative to the origin O, you've got these points. There's a fourth point. C says that ABCD is a parallelogram. You have to find the position vector of C. So ABCD is a parallelogram. We can draw a parallelogram here that looks like this, maybe. This is a parallelogram. You can mark these points like this. It doesn't matter which order you mark them in. Let's say A, B, C, D. Okay. Now, you know OA, OB, and OD. What you do not know is OC, position vector of the point C. You can use any parallel vectors. You can say AD, for instance, is parallel to BC. And they're equal as well. In fact, the opposite vectors are equal in the parallelogram as well. That means BC vector is equal to AD vector. Right? These vectors are supposed to be equal to each other. Now, what's BC? BC is OC minus OB. AD is OD minus OA. And then OC will turn out to be OD minus OA plus OB. Just input values here, you would get the position vector of C. You've got all of them, OB, OC, OB, OA, and OD. Okay, you can do that. And then you have to verify that the parallelogram is not a rhombus. What's the difference between a parallelogram and a rhombus? A rhombus is a specific kind of parallelogram that has all sides equal. If all sides are not equal, then it's not a rhombus. In a parallelogram, opposite sides are equal, but not all sides. So what you can do is, you can find the length of two adjacent sides, AD and AB, for instance. If their lengths are different, that means it's not a parallelogram. It's not a rhombus, sorry. Okay, so you can do that, pretty straightforward. In the next part, they say find an angle. You have to use that angle formula. The angle is at the point A, so you will be using the vectors AB and AD. Okay, both starting from A. Or you could use vectors both ending at A. That's your choice. You can find this angle. Then you have to find the area of the parallelogram, divide that into two parts, find the areas of the triangles, of one of the triangles, multiply that by 2. You've got the angle already. You have two sides as well, half AB sine C. You can use that for one triangle. So for maybe this triangle, and then just multiply that by 2. Okay, so this is fairly straightforward. You should be able to do it. Question number 9, again, I think this is also not that difficult. Let me see, u minus w equals 2 iota and uw equals 6. You just have to solve these simultaneous equations. Let me just connect my charger. Okay, it's done. Okay, so you just have to solve these simultaneously. The first part is fairly straightforward. The second part is about Argand diagram. So those, okay. Now, what do you do for this? I'll just tell you how to do it, or maybe we can actually just do this quickly. The second part, first part is pretty straightforward, right? You just have to solve simultaneous equations in the first part. Let's do the second part. Let's try to understand this. The Argand diagram is going to look like this. First of all, convert this to standard form. What's the standard form? It becomes z minus 2 plus 2 iota. That is less than or equal to 2. This is a circle, with this as the center and this as the radius. Then you have the other second inequality. That's a simple one. Argument of z is between 0 and pi over 4, and then real part of z is less than or equal to 3. So the only thing that we had to convert to standard form was this first one. We have done that. This is supposed to be the center of the circle, and this is supposed to be the radius of the circle, and you have to be inside the circle because it's a less than or equal to sign. Let's do that now. We've got 0 here. Let's mark this point first of all, 2 plus 2 iota. So let's say we've got 1 here and 2 here, and 1 here, and 2 here, 3, 4, 3, 4. Make sure the scale that you use in both axes is the same. Okay, now I don't think we need negative values here as such, so I'll just draw this part. This is the imaginary axis, this is the real axis. Okay, so the first locus is a circle because we're talking about 1 point and the distance from 1 point. That's a circle, okay? Radius 2, center at 2 plus 2 iota, that will be here. Let's draw that circle. Now, since the radius is 2, this circle has to just touch the x-axis and the y-axis. It should not be crossing those axes. That is important. It should just touch the x-axis and also just touch the y-axis at the point 2. Above, it should go up to 4 maximum, and on the right side as well, it should go up to 4 maximum. That's the circle. You have to be inside the circle because it's a less than equal to sign. Now, the argument has to be between 0 and pi over 4. Argument of z. Where is that measured from? From origin. So from origin, the argument has to be between 0 and pi over 4. Where is 0? 0 is this line. Pi over 4. Pi over 4 is a 45-degree line. 45-degree line means the gradient of that line is 1. It's going to be like this. This is a 45-degree line. Pi over 4 gradient. It has to pass through the center of the circle. Why? The angle is pi over 4. Pi over 4 or 45 degrees. What that means is whatever is the distance that you're covering horizontally, it should be the same distance that you're covering vertically. So if you're starting from 0, 0, if you go 2 units right, you have to go 2 units up as well. That means you pass through the center of the circle. This is the line pi over 4. Your angle has to be between these two lines, between the line where the argument is 0 and the line where the argument is pi over 4. You have to be between these two lines. That's the second condition, here and here, between the two lines. Okay, both of those conditions are met. What else? Real part of z is less than equal to 3. Real part of z. Where is real axis? On the horizontal axis. That means x is less than equal to 3. You have to draw the line x equals 3. That's a vertical line. That line looks like this. It's a vertical line. This is the line where the real part of z is equal to 3. Now, since the real part has to be less than equal to 3, that means you have to be to the left of this line. So which part is going to be shaded then? That satisfies all the conditions. You have to be inside the circle and satisfying these other inequalities as well. This is the part that satisfies all of those conditions, and that's what you would shade here. And that's your final result. Okay, I hope that makes sense. Now let's move on to the last one from this paper. Okay, so the last question. Question number 10, right? That's what you guys are asking about. Let's do this one and then we end. Now, a tank containing water is in the form of a hemisphere. The axis is vertical. The lowest point is A. This is vertical, the axis of the hemisphere. The lowest point is A and the radius is R. The depth of water at time t is h. Depth means height of water, right? Or the depth of water, that is h. At time t equals 0, the tank is full and the depth of the water is r. Okay, so hemisphere. We know the formula for volume of a hemisphere. For a sphere, it's 4 over 3 pi r cubed. For a hemisphere, the volume formula would be 2 over 3 pi r cubed, right? Half of that. In fact, they have given us this here. Okay, so they've actually given the volume formula in terms of H, not in terms of R. All right, we'll use that. The depth of the water at time t is H. That's another variable. So we've got H here as well. We're talking about time. At time t equals 0, the tank is full. So that means at time t equals 0, the volume of water in the container is the same as the volume of this hemisphere because it's full. At this instant, a tap at A is open and water begins to flow out at a rate proportional to square root of H. The tank becomes empty at time t equals 14. So when the time is equal to 14, tank becomes empty. The volume of water in the tank becomes 0. Volume of water in the tank is V when depth is H. It's given that V equals this. We have a relationship between volume and height that they've given. Show that H and T satisfy a differential equation of this form, where B is a positive constant. Now, how do we think about this? Okay, so the tank is full initially. Initially, it says the tank is full. And the water just begins to flow out then. What's the rate of outflow of the water? It flows out at a rate proportional to square root of H. What does that mean? Water is measured in terms of volume. dV over dt. dV over dt, what is that going to be? That's going to be minus K into square root of H, right? It's flowing out. Its rate of decrease. The change is negative. So when we talk about dV over dt, it's going to be negative like this. Minus K into square root of H. Now the problem is we have dV over dt. What we actually wanted to find out was dH over dt. For that, we would have to use chain rule now. Remember, that's what we do when the information given is in terms of one variable. In this case, they gave information about the volume. And then what they want you to prove is in terms of H, you have to use chain rule for this. How would you do that? You've got V in terms of H here. Let's find the derivative of this to find dV over dH and see what that turns out to be. 1 over 3 into pi, that's a constant that remains as it is. Why did we add minus K? It's proportional to square root of H, right? The water is flowing out. Since it's flowing out, it's negative. K is proportionality constant. And we are saying K, the value of K is supposed to be positive, right? That's why we're putting negative sign outside. Because they're talking about outflow in this case. We have to put a negative sign there explicitly. Okay? So K is proportionality constant, we have a negative sign outside. Okay. 1 over 3 pi into 3 r8 squared. What's the derivative of this? Now, what's the radius? Okay, now think about it. Radius is also fixed. Okay. Radius of this hemisphere, that's not changing. That's fixed. So 3r, that's also a constant. 3r is also a constant, right? So 3r also remains as it is. What's the derivative of h squared? 2 times h. This is what we get. Minus the derivative of h cubed, that will be 3h squared. Now let's simplify this. It becomes pi over 3 multiplied by 6rh minus 3h squared inside. Divide each term by 3. 6 over 3 gives you 2. That's 2 pi rh minus h squared. That is dV over dH. Now, what is dH over dt going to be then? What do you use for that? You use chain rule for that. dH over dt, that's what you want to find out. So you can say dH over dt, that equals, you have two fractions. In the first fraction, you have dH as the numerator. In the second fraction, you have dt as the denominator, pi h squared. Okay, thank you for that. We have pi h squared here. I did not multiply by pi here. This was pi h squared. Thank you. Okay, so dH over dV into dV over dt. That's the chain rule that you would be using here. What's dH over dV? Reciprocal of this. What does that become? 1 over 2 pi RH minus pi h squared into dV over dt, which is this thing, that's minus k into square root of h. Now we need to somehow convert it to this form. How do we do that? In the denominator, we have 2 pi RH. Pi is not there, so we have to take pi common outside. Let's do that. Let's take pi common outside. And in the numerator, we've got minus k as well. I'm taking minus k over pi common outside. What are we left with inside? In the denominator, we have 2RH. 2RH is for 1 over 2 and minus h squared. Okay, let me write it like this first. In the numerator, it's under root h. That's h raised to the power 1 over 2. In the denominator, we're left with 2RH minus h squared. Right? Now, this h power 1 over 2, I could take that to the denominator, right? Because in the form that they don't have any h in the numerator. So I can take that h to the denominator. If I do that, I can write this as 1 over h raised to the power minus 1 over 2. Right? I've taken this under root h to the denominator. And now if I multiply that inside, that gives me minus k over pi into 1 over 2r h raised to the power 1 minus 1 over 2. What does that become? 2r h raised to the power 1 over 2 minus h squared into h raised to the power minus 1 over 2. 2 minus 1 over 2, the power becomes 3 over 2. And that is what we wanted in the denominator there. 2r h raised to the power 1 over 2 minus h raised to the power 3 over 2. And now they're saying b is a positive constant. Now you see, we've got this constant here. Our constant is k over pi. K is a constant, pi is also a constant. We can say this whole thing is a constant. So we could say b is, we could write this as another constant, and they're calling this constant b. We know that k is positive, pi is positive. We can say b equals k over pi, and we could write this differential equation as dH over dt equals minus b over 2r h raised to the power 1 over 2 minus h raised to the power 3 over 2. Okay, so we're just treating this fraction as just another constant, and they named this constant b, so we are naming that b as well, and we say, okay, this can be written in this form like this. That's your differential equation. That's what we wanted to prove in the first part. Make sense? That's the first part. Now it says solve this differential equation or obtain an expression for t in terms of h and r. How would you solve this differential equation? Now you have to separate the variables. Remember, r is a constant. Treat this as a constant that will remain as it is. You have to find your answer in terms of r. Okay. All right. So what do we do for this? Let's separate the variables. This will come to the left side, and it becomes 2r h raised to the power 1 over 2 minus h raised to the power 3 over 2 whole times dh. On the right side, you have minus b dt. Let's integrate both sides. We have separated the variables. There was no t here, so we just had to take h to the left side, and we have done that. Let's integrate the left-hand side. 2r is a constant that remains as it is. Integration of h power 1 over 2. Add 1 to the power, it becomes 3 over 2. Divide that by that new power. Minus h raised to the power 5 over 2. Divide that by that new power. That's 5 over 2. On the other side, What's the integration of minus b? It's minus b times t, and you have a plus c here as well. Okay, this is what we get. Now, what do you want to find out? You want to find t in terms of h and r. We need to find the value of b and c somehow. How do you do that? What information do we have? We know that when t was 0, the tank was full, and when t was 14, the tank was empty. Okay. Let's use this condition first. When time is 14, tank is empty. What's the variable that we have? H. Depth of water will be 0. That's 1 point. T equals 14 and H equals 0. Let's put that here. We say let's input T equals 14 and H equals 0 first of all. Let's see what that gives us. 2 goes to the numerator here. It becomes 4 over 3r. In place of h, put 0. 0 raised to the power 3 over 2 minus 0 raised to the power 5 over 2 over 5 over 2 equals minus b into 14 plus c. We get an equation in terms of c and b. It's going to be 14b equals c. That's one equation. Now what we do is we put the other value of T and H. What's that other value? Do we have another information given here? Depth of water at time t is H. At time t equals 0, the tank is full. Now, when the tank is full, what's the height of the water? The radius of the hemisphere was r. So the height of water is r at time 0. So at time 0, what this means is H is going to be equal to R. That's what you input here. Since you want your answer in terms of R, that's all right. Now you say, let's input T equals 0 and H equal to R in this equation. What does that give us now? 4 over 3. Again, this 2 goes to the numerator. It becomes 4 over 3 into R raised to the power 3 over 2 minus. I can take this 2 to the numerator as well. It becomes 2 over 5. H raised to the power 5 over 2. That means R raised to the power 5 over 2. On the other side, you have minus b into 0 plus c. What does that give us? 4 over 3 r raised to the power 5 over 2. 1 plus 3 over 2, that's 5 over 2 minus 5 over 2 raised to the power 5 over 2 into r raised to the power 5 over 2. That equals c. This is the value of c that we're getting. If this is the value of c that we're getting, what's the value of b going to be then? This whole thing divided by 14. So 14b equals c, right? That's what we got earlier. We can just use that. We can say 14b equals c, and that will give us the corresponding value for b as well. Let's do that. Is this all right until this point? 4 over 3 r raised to the power 5 over 2 minus r raised to the power 2. 2 over 5. Okay. Yeah. Thank you. This is going to be 2 over 5, not 5 over 2. Okay, so that's C what we're getting. Now, let's find B as well. If we know that this is C, what about B then? 14B equals this thing. So B would equal 1 over 14 times 4 over 3 r raised to the power 5 over 2 minus 2 over 5 r raised to the power 5 over 2. That is going to be the value for B. Okay, that's what B turns out to be. Now we simplify this and see what that gives us. Where do we need B at the end? B into T, and we want to make T the subject at the end. Okay, all right. So this is what we get. If we want to simplify this, we can do that. Let's simplify this and see what that gives us. 4 divided by this 2 over 21. 2 over 21 r raised to the power 5 over 2 minus 2 over 5 and 14. That's 1 over 35. 1 over 35. We could actually simplify this. Why did I not simplify this actually? Couldn't we simplify this? C actually becomes 4/3 minus 2/5. These are the same terms. This is actually giving me 14/15. 4/3 minus 2/5. 14/15 r raised to power 5/2. We could actually simplify that first, and then we could input that here. That makes things simpler. So it's 14/15 r raised to power 5/2, and that actually becomes b equal to 1/15 r raised to power 5/2. This is what b turns out to be. Okay. Now we've got c and b. Now put these values back in that original equation and see what that gives us. Again, I'm writing 2 in the numerator. It becomes 4/3 r h raised to power 3/2 minus 2/5 h raised to power 5/2. On the other side, you have minus b. B is now known. That's 1/15 into r raised to power 5/2 times t plus c. C is 14/15 r raised to power 5/2. You just have to make t the subject now. So take all terms to one side. Apart from t, it becomes 4/3 r h raised to power 3/2 minus 2/5 h raised to power 5/2 minus 14/15 r raised to power 5/2. On the other side, you have minus 1/15 r raised to power 5/2 times t. Just multiply this whole thing on the other side, and that will give you t equal to, I'm multiplying 15 on the other side, and r will go to the other side. It becomes r raised to power minus 5/2. This goes to the other side. It becomes 1/r raised to power 5/2, which can be written as r raised to power minus 5/2. And then 15 goes to the other side. It gets multiplied. This negative goes to the other side as well. I'm multiplying the left side by minus 15. Okay. Let's see what that gives me. 15 into 4/3, that's 20. So I'm getting minus 20 r into h raised to power 3/2 plus 15 into 2/5, that's 6 h raised to power 5/2 plus 14 r raised to power 5/2. And this is t in terms of h and r. You could simplify this. You could multiply that r inside if you wanted. If you do that, it becomes minus 20 r raised to power minus 5/2 plus 1. That's minus 3/2 into h raised to power 3/2 plus 6 r raised to power minus 5/2 into h raised to power 5/2 plus 14 into r raised to power this into r raised to power this. That just becomes 1. So it's r raised to power 0. Now, if you want, you can write it like this: minus 20 h raised to power 3/2 over r raised to power 3/2 plus 6 h raised to power 5/2 over r raised to power 5/2 plus 14. This is t in terms of h and r, and that is what we were looking for. Make sense? That's your final answer. T in terms of h and r. That was a bit complicated, not in terms of the concept, but just the working, because there was a lot of room for careless errors because of the letters involved, h, r. But I hope that makes sense. That's it. That's it for today. I'll see you again in the next class. Then in the next class, we will be doing 2 other papers from 2020, difficult questions from there. I'll see you again in the next one then. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.